Hello everyone. This is Pratik Further, and I'm in group number 8. And now I'm going to tell you about vector space classification with multiple classes. So, in its most basic type, SVM doesn't support multi-class classification. For multi-class classification, the same principle is utilized after breaking down the multi-classification problem into smaller subproblems, all of which are binary classification problem. The most popular or the most used methods for SVM are one versus one approach, one versus all, and directed acyclic graph approach. So what is one-to-one approach? So this technique breaks down our multi-class classification problem into sub-problem, which are binary classification problems. So after this strategy, we get binary classifiers for each pair of classes. For final prediction for any input, use the concept of majority voting along with the distance from the margin as its confidence criteria. So for example, let's take three classification problem. Here on the right side, we have a figure which shows red, green, and blue dots. In one-to-one approach, we try to find the hyperplane that separates between every two classes, neglecting the point of the third class. For example, here red blue line or blue green line or green and red line. These two lines actually separate two colors from each other, and they don't take the third point into consideration. That's what one-to-one approach is. If we move on to one versus all approach, we try to find a hyperplane to separate the classes. This means the separation takes all points into consideration, divides them into two groups, in which there is a group for one class points and the other group for all other points. For example, as you can see the green line, which tries to maximize the gap between the green points and all others. Same goes to the blue and same goes to red. That is the one versus all approach. So there is also the last thing, which is directed acyclic graph. This approach is more hierarchy in nature, and it tries to address the problem of one versus one and one versus all approach. There is a graphical approach in which we group the classes based on some logical grouping. So what are the benefits? Benefit of this approach includes a fewer number of SVM trains with respect to the OVA approach. It reduces the diversity from the majority class, which is a problem of OVA approach. I think that's it from me, guys. Thank you.